Okay, so today is lesson 6.6, and I'm going to skip the main part of the lesson because it's an algebraic proof of the Pythagorean theorem, and because I'm running short on time, I'm going to skip to the ready for more section. So go ahead and skip those slides and go all the way to the ready for more. Now, we're going to be doing, there's theorems that I need you to know in order to move forward. So it says the right triangle altitude theorem 1. If an altitude is drawn to the hypotenuse of a right triangle. So first, what are they talking about? So if you have a right triangle, I'm going to do my best to draw a really good right triangle, right? So here's my right triangle, okay? And they said if an altitude is drawn, so I'm going to talk about this guy. So pretend that this is a weird building, and here you are at the tippy top, right? And what's going to happen is you're going to drop a rope straight from the tippy top all the way to the floor. That would be your altitude, okay? So an altitude is also known as the height of something, okay? So this is your altitude. Specifically, this is the altitude to the hypotenuse of a right triangle. So notice the two theorems that I'm going to give you both start off exactly the same. If an altitude is drawn to the hypotenuse of a right triangle, if an altitude is drawn to the hypotenuse of a right triangle, okay? And so we want to talk about what happens, okay? So it says the length of the altitude is the geometric mean between the lengths of the two segments formed at the hypotenuse. And you're like, what? So let me just share with you a couple things, okay? So it's the geometric mean. Whenever they say this geometric mean, it means, so I'm going to call this guy H. So whenever they say the geometric mean, you're going to write this proportion. And the geometric mean means he goes here and here. And then it says between the lengths of the two segments formed by the hypotenuse. So we're saying this piece here, I'm going to call him A, and this piece here B. So we go like this, okay? So because we have the altitude drawn to the hypotenuse of a right triangle, we get this proportion. And I know you're thinking, okay, like what? So the way I'd help my students remember this is I'd say altitude, altitude, piece, piece. So I want you to remember that these are, hold on. These are the pieces of the hypotenuse. I thought I was going to be done coughing. The segments formed. So altitude, 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 piece, piece. We're going to do a practice problem like this. So we're going to head over to your, well, actually, we're going to do a couple practice problems in a second, okay? So the next one is, and I'll just use the same drawing because why not? It says the altitude of a hypotenuse, the altitude is drawn to the hypotenuse of a right triangle. The length of each leg of the right triangle is the geometric mean. Okay, so when they say geometric mean, I'm going to draw this proportion again. And then they said the leg. So I'm going to go with leg, right? Right? So that's my L's. They're supposed to be L's. Okay. Is the geometric mean between the length of the hypotenuse. So the length of the hypotenuse, I'm going to go this guy here, and he's going to be C. And the length of the segment on the hypotenuse adjacent to the leg. So whatever piece is adjacent to it. So if I'm using this leg, if I'm using this piece here, then I'm going to use A. But if I'm using this piece here, I don't know, I'm going to call this X, then I'm going to use this one. So because I'm using that one, leg, then I'm going to use this letter A. Okay. So there's your, and then so the way I'd make this one. So this one, this guy up here is called altitude, piece. So altitude, I say this, altitude, piece, because people, I don't know why, but they'll remember this rather than the geometric mean. So just remember that the altitude is here and then the pieces go there. This one, I say leg, piece, hole. Leg, piece, hole. And by hole, I mean the whole hypotenuse. Okay. So when we do this problem down here, we're going to use both of those theorems to solve this. Okay. So I don't know about you, but the one that stands out to me, I don't know this other piece, so I'm not going to use this one. I'm going to use leg, piece, hole first. So I'm going to go over here and I'm going to go leg, piece, hole. So I have Y. So I get Y here, Y here. I get the piece, which is 6, and I get the hole, which is X. Okay, and that's one equation with two variables. That's not very good. Okay, and then the next one I will try is, I'm going to try writing the other one, which is altitude, piece. So I'm going to go altitude, piece. So I go 8, 8. So you put those diagonally there. And then piece. Now this piece here is 6 for sure. And this piece here is the rest of, I'm just going to label him B just because I can. So that's B. And I can solve this equation, right? So I'm going to multiply both sides by B. Okay, so if you can write this equation out and this equation out, that's it. Now I've transported you back to like 7th and 8th grade for you to solve the rest of this. So one more time, it's either going to be altitude, piece, or leg, piece, hole. And for this one here, now I'm going to go into solving mode. I'm going to multiply both sides by B because then these would cancel, right? And then I'm also going to multiply by 8 because then these would cancel as well. Okay, so here I get 6B equals to 64. And then if I divide, I get B is equal to 64 over 6, which is yucky. I'll do 2, so that's 32 divided by 3. And I like fractions. I don't like decimals, so I'm going to leave my answer alone. Okay. If you want to put decimals in there, you can, but I personally, as a math teacher, improper fractions are fine. Decimals are a little bit more rounded. Okay, so if I put this here and I say that this little part here is now equal to 32 over 3, I can now add those two together, right? And now I know what X is, right? So whatever 6, so I'm going to add 6 plus 32 over 3. Now I could do this in Desmos if I want, and I'll do it just so you guys see. So I go 6 plus 32 over, oops, what happened? 32 over 3. And I get that. And if I want it to be a fraction, then I'm going to push this little button right here. So I click that, I get 50 over 3. So now X is equal to 50 over 3. And now I'm going to solve this equation over here. So I'm going to put my 50 over 3 in here. And I'm going to solve it the same exact way. So I'm going to multiply both sides by Y. And then I'm going to multiply both sides by 50 thirds. And a bunch of things will cancel. So I get Y squared equals to, let's see. These two will cancel, leaving a 3. So that's 150. Let me do that right. Hold on a second. Let me check my math. All right, I multiplied wrong. 6 divided by 3 is 2, not 3. So this is 100. So that means y equals to plus or minus 10. But notice that y is the length of a side, so there's no way you could be negative 10, so y is 10. Okay, so I'm going to show you one of your ready, set, goes. So go ahead and open up your ready, set, go so that we can do this. Do not do number 2. Do not do number 2. Skip it. It's going to confuse you. So if you do, I want you to do these 4 problems, and then we're going to check them. Do your best to do them to make sure that you are ready for this, okay? You are able to do the exit ticket and everything else. So have a great day, and I'll see you on the next video.